vintage equipment. This here is a Victor Medalist 204 calculator. This here is a calculator that dates from the late 1970s. They made them from about 1976 onwards, maybe 5 years or thereabouts. I've had this unit for almost 15 years, maybe even longer than that. Got it for free way back in the old days. And I really like this machine. It is ideal for certain jobs where you need to add up just a shit ton of numbers. You got like hundreds and hundreds of these numbers that you got to add up, where it's not really worth busting out a computer spreadsheet or something like that. You just got to add some numbers up. It is perfect for that because the keypad is full size. It's really, really sweet, really easy to actuate. You can be holding your numbers in one hand, and you don't even need to look at the keys to actually be entering the numbers. A little dot there on the 5. Trying to demonstrate something here. I'm not having a whole lot of luck. And what I'm trying to demonstrate is, well, the keypad has been developing a bit of keyboard bounce. And in keyboard bounce, what happens is, well, sometimes you press a key and it doesn't register, and sometimes you press a key and, well, it registers 2 or 3 times. I can't get it to show at the moment, but it happens. Trust me on that. Yeah, let's take it apart, see what's inside, and clean up the key contacts and put back together. Turn it off. I love how the display does that. Take out the kettle cord. It's not really a kettle cord, but it's a lot easier. It's just a nickname. It's a lot easier to remember than the IEC, International Electrotechnical Commission C13 connector. Not actually rated for high heat like it's used in kettles, but it sort of looks like a plug that you put into kettles, doesn't it? Anyways, let's turn this puppy over and just see the bottom here. We got the Victor Comptometer Corporation. Victor is a long-standing organization. They were founded, I think, in 1918, and they were making adding machines for the longest time. They were quite successful at it. They were the #1 adding machine company in the world, and they ended up expanding, and they went through various sorts of company acquisitions, and then they were acquired by other companies and so on and so forth. They acquired a computer company, I think in the late 50s or the 60s, can't remember. They acquired the Comptometer Corporation, and they got into producing electronic equipment. By the mid-1960s, they had one of the earliest electronic calculators. Anyways, I see here 3 screw holes, and I like that these feet are, these rubber feet, they're actually put into, well, they're a little standed off, and then they're stuck into, yeah, that's not nice. I don't want to pull it out if they're glued in, but it seems like they're just plugged in. Pop one out. Maybe I won't do that. I don't want to break them. They don't come out that easy. Anyways, those are I think they're around #1 Phillips screws. And does this come off relatively easily? There's the screws. Isn't that interesting? They're actually machine screws, so they must have threaded inserts in the plastic. That's nice. Dump those over there. Okay, there's the top. Oh, something loose in there. That's a key. That would be the control for how many digits you would like to round your number to. There's the slider for that. Oh, there's the inside of this puppy. Now, let me just pause the video here, and I'm going to start taking this apart a little bit further, and I'll bring you right back. So here's the keypad separated from the rest of the unit. Really quite a lovely construction with this solid metal frame, and uses discrete switches, really quite nice discrete switches. As you might expect for an old machine like this, the keypad is filthy as hell. Off a camera, I'm going to take all the caps off, and I'm going to give it a good proper cleaning and squirt some deoxit into the switches. Hopefully that fixes it. There's the connector on the back. Now let's take a look at the main board. The main board is really simple, especially compared to calculators maybe only 5 years earlier than this. They would have been a nightmare of circuitry. This here, everything is done on one chip. That's a Rockwell chip, Rockwell 4540, and the date code says 1976. That puts this whole unit, well, somewhere a little bit thereafter, maybe 1977, it was put together. The circuit board here, we can see, well, that side there's going to be all power supply. There's a chip that does everything. It pulls the keypad, it does the calculations, and it's going to determine what segments of this display to run. The only other circuitry is a whole bunch of these transistors, these little black boxes. And what these transistors do is they run the display at its proper voltage, which is, well, different than the chip. This display is probably running a couple dozen volts, let's say. Construction is really, really sweet compared to modern equipment. Notice the metal frame all at the back. This metal frame, it's not the plastic, but this metal frame which is supporting this somewhat heavy transformer, a fuse, as well as the kettle plug inlet here, IEC14 that would be. Yeah. So anyways, let me get on to cleaning up the keypad, and I'll bring you back, and maybe we'll look at that display. These VFD displays are pretty neat. So here's a close-up of the VFD, the vacuum fluorescent display. I thought it'd be worth a go-through of how this thing operates. Kind of a cool device, and they're still relatively common. However, they're becoming less and less common as new technologies are taking over. More and more we're seeing LED displays and OLED, organic light emitting diode displays, and these are becoming a little bit less frequent. They're going to eventually die out. So anyways, what we got here is a glass vacuum chamber. So all the gases have been evacuated out of here. And this operates rather like an old school tube, electronic tube, a vacuum tube. It has three different components. It has a cathode, it has an anode, and then it has these control grids. Let's first of all look at the cathode. The cathode are these very, very fine wires, and you can see two of them that I'm roughly pointing at there. Those wires are made out of tungsten, and they are heated up. A small current runs through them. It doesn't need to be a very strong current because they're such thin wires, and it heats the wires up to maybe about 650 degrees centigrade, something like that. And these wires, they're coated with some metals and some metal oxides, and these metal oxides, when they're heated up like that, they release electrons into this vacuum area. Now, what's also needed is a control grid, and that is these plates that I'm pointing at one there, these square plates. They're made out of stainless steel, and they've been etched in such a way that they form like, well, they're porous. These plates, they're positively charged, and what that does is it attracts the electrons that are liberated from the cathode, and it causes the electrons to evenly diffuse over the space. And then behind the grid, we can see here in white in this non-illuminated digit, we can see these segments, and these segments are made out of carbon, which is conductive. And these carbon segments, they're coated with a zinc compound. I think it's a zinc oxide. And so these cathodes, they make electrons, and these grid plates, they attract the electrons and they diffuse them. And then the anodes, when one of these segments gets a positive charge, that attracts electrons. The electrons bombard the segment, and the zinc oxide, it illuminates, it glows. So anyways, that's the basic way that these displays operate. Now you might notice that this display is flickering, and that's because it's multiplexed. Multiplexing makes it possible to have a rather complicated display with lots and lots of segments that need to be lit up with a minimum number of wires. So all that's required to run this is, well, two wires, two leads to power up these cathodes, to heat them up and make them hot. And then a lead is needed for each control grid. And in turn, these control grids are switched on and off, and that's why the digit is flickering like that. In turn, each one is switched on and off, and then there's some other leads. I'm pointing at one right there, and these leads, well, they're going to go to each one of these segments across the entire display. And by determining which control grid is being turned on and which segment is being turned on and alternating that in sequence, it's possible for this calculator to get, well, a 7-segment display multiplied by 12 digits, and there's a couple extra special ones at the end, a memory and an error and a negative symbol. So anyways, that's the basic function of these VFD, operation of these VFD displays. Kind of sad that they're disappearing, because they're nice, they're pleasant to look at. This zinc coating, it fluoresces at, I think, around 505 nanometers. That's that teal, bluish green color. That's rather close to the human eye's optimal sensitivity. What that means is that it's easy to focus on these digits. They're fairly easy to look at. They're easy on the eye. They are unfortunately being replaced by LEDs, and LEDs, for some stupid reason, manufacturers are going towards these blue LEDs. And these blue LEDs, they're monochromatic light, and they're at a shorter wavelength. They're a deeper blue. And they're a lot harder on the eyes. They're a lot less easy to focus on. Here's one from my Samsung microwave oven, and you can see it's pretty, I guess, pretty shade of blue, but not very easy to focus on. Not very pleasant. Not a good human interface. So I broke out my oscilloscope so we can check out how this display is operating, how it's multiplexed. Let me just put the probe on the control grid for that first digit. Let it stabilize, and what we see is that digit is only on for about 1 millisecond every 7 milliseconds. Yeah, this human persistence of vision means that you don't detect it. Your eye doesn't detect it. It looks like it's a solidly lit digit. Of course, on this camera, the camera's kind of picking up a little bit of a flickering there, but your eye doesn't see it. Now let's talk a little bit about theory of operation. This has an adding machine heritage, so it operates a little bit differently than your typical handheld calculator. Notice that addition and subtraction are on one side of the keypad, while division and multiplication are on the opposite side. Reason for that is this machine, you're typically going to be doing addition and subtraction the most frequently, and it makes it really easy to do. Let's just add up a 1 through 5. Now, if you do want to do division or subtraction, it's not too difficult either. Let's figure out the average of those numbers I just entered. Divide it by an n. Well, that is the count of how many times you hit that positive button, how many times you hit the addition button. And to get the answer, you can't hit that again. You have to now hit the equal symbol, and you get an average of 3.0. Pretty cool. What else does this machine have? Oh, it has this little swapping function, which is pretty cool. Let's add 1, 2, 3, and 4. And what the swapper does is it changes what is displayed with the last entry. So the last entry would have been 4, and that displays the 4 that we just entered. Enter that, type it again, and you go back to our result. It operates a little bit weirdly when you're doing the subtraction, the multiplication and the division key, but oh well. It has variable precision. Rounding, automatic rounding of your numbers, and you can select any number of different digits here. Really handy for when you're having to deal with lots and lots of numbers. Then you don't have to do it in your head. The machine does it for you. This switch here sets what type of rounding you're doing, whether it is rounding to the nearest whole number or a modulus down to the integer, or for some reason, I'm not sure why, but I guess in certain circumstances you might want to round numbers up. It has a single memory register, and it has these traditional symbols for memory display, and M star is memory clear. Let's try that out. Let's put 2 into the memory and then 3 into the memory, and we display it, and that shows you 5. M star, that kills the memory, and the little memory symbol disappears. There's 2 additional buttons on this side that are also toffee colored like these, and as far as I can tell, these are the same as M plus and M minus. Let's just try that out. Put 2 in, M plus. Put 3 in, plus equals. And, well, yeah, it just adds it or subtracts it from whatever's in the memory. It has a percent key, clear all, clear entry, and otherwise, that's a pretty simple interface. really easy to use, and I really appreciate that. Anyways, thanks for watching. I hope you found this interesting or entertaining, and well, I'll see you next time. Bye-bye.